Good morning, class 12. As you know that the chapter chemical kinetics is over now. So in today's session, I'll be discussing with you the important numericals from NCERT book, and it will be a sort of revision of the entire chapter. So before I proceed, children, please, it's a request. You also keep on practicing the numerical along with me, along with the explanation. So carry a pen and copy with you. So here is the first question. The first question is, for the reaction where R is getting converted into P, the concentration of a reactant changes from 0.03 molar to 0.02 molar in 25 seconds. So you can see here that change in concentration is given in the question. From this point you can find out the change in concentration, the final minus initial, and in 25 minutes, that is delta T is also provided to you. Calculate the average rate of the reaction using the units of time both in minutes and second. That means you have to find out both in minute and seconds. So average rate, you have already done this formula. It is equal to delta R, that is change in concentration. Since here the reactant is R, so it is written in with respect to R only, delta R upon delta T. So delta R is equal to R2 minus R1 upon T2 minus T1. So delta R, that is R2 minus R1, can be written as 0.02 minus 0.03. As you can see here, 0.02 minus 0.03, and negative sign is already present here. Negative sign indicates that we are talking about reactant. Since the concentration of the reactant goes on decreasing with the course of the reaction, so to keep the rate of reaction positive, the negative sign is placed here. These things are already explained to you in the previous video session. Okay, so now let us move to the numerical. R2 minus R1 upon T2 minus T1. So it will be minus 0.02 minus 0.03, final minus initial, upon 25, which is change in time. Since we are using the time here in minute, so it will be molar per minute. Molar means moles per liter. So moles per liter is also molarity only. So you can use capital M in order to represent moles per liter, or you can write here moles per liter per minute. Okay. Now on calculating, you will get minus 0.01 upon 25, and then final answer will come out to be 4 into 10 raised to the power minus 4 molar per minute. Now when you have to convert it into second, what will you do? You will divide it by 60. And when you will divide it by 60, the answer will be 6.67 into 10 raised to the power minus 6 molar per second. So this is how we solve these numericals. And children, we have already practiced a number of numericals based on these calculations. And you might get this in 1 or 2 mark question in your board examination. So do practice such questions. Okay, now moving on to the next numerical. The next numerical is the conversion of molecules X to Y follows second order kinetics. Second order kinetics. Okay, so these points are to be noted whenever you are solving a question. Second order kinetics is being followed here. If concentration of X is increased to 3 times of its initial value, how will it affect the rate of formation of Y? That means the reaction is as follows, as you can see here, and it is following the second order kinetics. So the rate can be expressed like this. Rate is equal to, or I am writing it in a simple way, R is equal to K X raised to the power 2. Okay, instead of using this, children, use this equation. And let A moles per liter be the concentration of X, then the equation 1, and now the equation 1 is this one. This is your equation 1. Can be written as R is equal to K into A square, as you can see here, because the concentration here is taken as A. So finally the rate will come out to be Ka square. Now when the concentration is increased to 3 times, concentration is increased to 3 times, means now the new value of the concentration will be 3A, as you can see here. Now again, formulating second equation, the rate can be written as R is equal to K into 3A whole square. So this will be your equation 2. Now when you will expand this equation, solve this equation, you will get it as 9Ka square. Now when you will this divide equation 1 by equation 2, like R1 by R2, what will you get? You will get it as Ka square upon 9Ka square. So this Ka square will get cancelled off, and finally you will have R1 by R2 is equal to 1 by 9. So what will be the relation between the two? It will be 9R1 is equal to R2. That means the rate of reaction will increase by 9 times. Okay, the rate of reaction will become 9 times of its initial value. So solve this question on your own and then compare the answer. So coming to the third numerical. The third numerical is a first order reaction has a rate constant of 1.15 10 raised to the power minus 3. It means that there is an into sign in between, which is missing here. How long will 5 gram of this reactant take to reduce to 3 gram? Okay, so again you have initial and the final values, and the value of K is also given. Okay, there should be a multiplication sign. So from the question we can write down the following information. Initial amount is 5 gram, final amount is 3 gram. The rate constant is this. Again reminding you, there should be a multiplication sign in between, which is missing here. We know that the first order reaction, the expression for the first order reaction is this. This should be on your tips, children. Whenever you see first order reaction, you should immediately recall this expression, where T is equal to 2.303 upon K log of A naught upon AT. In this case it is R naught upon R, whatever alphabet you want you can use. R naught is the initial concentration, R is the leftover concentration. So what will happen? The equation will get modified as 2.303 upon 1.15 into 10 raised to the power minus 3, as you can see here, into log of 5 upon 3, because it has reduced to 3 grams. As you can see in the question, it has reduced to. That means this is the leftover. This is the final concentration. So you can use these concentrations directly here. It is given in gram, but there is no need to convert it into concentration. Why? Because whatever volume will be for this, the same volume will be for this. So if it is per liter, then obviously liter and liter will get cancelled off. So you can directly use 5 upon 3. And on simplifying this, on solving this, you will get the answer as this. So I hope it is clear. Log 5 upon 3, the values will be provided to you. The log values will be given to you. So don't worry about the log values. Okay, now see the next question. What will be the effect of temperature on rate constant? This I have discussed in my very recent lectures, where I discussed with you the Arrhenius equation. So try to write down the answer on your own. This is also a board question. This has been asked in your board also. Now move on to the next numerical. The rate of the chemical reaction doubles for an increase of 10 Kelvin in absolute temperature from 298 Kelvin. Calculate activation energy. This is again based on the last concepts that we did. So it is given that temperature T1, as you can see here, temperature T1 is 298 Kelvin and T2 is increase in temperature is mentioned in the question, which is 10 Kelvin. So T2 will be 298 plus 10, that is 308 Kelvin. So we have the values of T1 and T2, and it is given that the rate of the reaction doubles itself. So obviously the rate constant will also double itself. So wherever you are using this expression Please see this expression, children. You can see here the expression is given. If you remember, I discussed it in the last session. Log K2 upon K1 is equal to E upon 2.303 R into T2 minus T1 upon T1 into T2. So we have all the values with us. We have both the temperatures with us. We have the value of this log K2 upon K1, and obviously constants are given. Now you have to find out the value of activation energy. How to find out log K2 upon K1? As you know, in the question it is mentioned that the rate of chemical reaction doubles for an increase of 10 Kelvin. So doubles means when you write down the value of log K2 by K1, that means K2 is twice K1. That means you can write log 2K1 upon K1, because K2 is twice of K1. So this will get cancelled off. Finally, you will get the value as log 2. So this is what is used here. You can see here that finally on substituting the values, I hope if you are clear with the concept, you can substitute all the values on your own, and I am directly coming to this step. The details you can study on your own, and then simplifying the equation or making activation energy as the subject of formula, and then you will get the answer as 52897.78 joule per mole. The answer might vary a little from the answer given in NCERT. You can tally, and then in kilojoule you can write down it as 52.9 kilojoule or directly 53 kilojoule per mole. So I hope this numerical is clear to you. So practice these numericals, children, on your own, and then ask if you have any confusion in any of these steps. So here is a very simple numerical. Calculate the half-life of a first order reaction from their rate constant given below. Rate constant is given in front of you, and with the help of the formula you can directly substitute the values and calculate the value of T half. So you simply copy down this numerical and try to solve it on your own and tally the answer. This is simply just to substitute the values in the formula of half-life. T half is equal to 0.693 upon K. So K's are given with different units and you will get the answer. That's it. So come to the next numerical. Next numerical is a first order reaction takes 40 minutes for 30% decomposition. Calculate T half. Yes, 30% first order reaction is undergoing 30% decomposition. That means if the initial concentration you are taking as 100, when we are talking about percentage, obviously the initial will be 100. Then the leftover will be 100 minus 30, because it has already undergone dissociation, 30% dissociation. So the leftover will be 70. So the equation will have A0 upon 80 value as 100 upon 70. Now using the first order equation which I told you to remember, T is equal to 2.303 upon K log R0 upon R. Now substituting the values, as you can see here, everything is given. 40 minutes is given as the value of K. Value of T is given to you as 40 minutes, and rest this I explained you how come you got 100 upon 70, and then rest everything is just substituted and you will get the value of K as 8.918 into 10 raised to the power minus 3 minute inverse. Now again this value, the value of log 10 is 1. This will be calculated by converting it into log 10 minus log 7. If you remember from the video session, I told you whenever log is in division, it gets converted into subtraction. So log 10 value, you know, it is 1. Log 7 value will be provided to you. Okay. So now when you have the value of K, by using the formula for T half, you can use this expression. As you can see here, this expression is given. The value of K can be substituted and you will get the answer as 7.77.7 minute, as you can see here. So this is how you will reach to the answer. So keep on practicing some more numericals, children. This is the last numerical for today, and you have many more such numericals in your NCERT also. Solve the in-text question. Till the time you are not clear with the concept, keep on practicing. The more you practice the numericals, the more will be clear your concepts. So please practice, children, as much as you can. And the chapter is finally over. We are done with the questions, with the theoretical explanation and everything. And since it is a part of physical chemistry, it is 100% sure that you will get a numerical based on this. And important theoretical questions also I discussed with you in one of my video lecture. Keep on revising, and thank you for watching the video sincerely and regularly.